Hello everybody, this is Stephen Whitfield, a drilling contractor here at the IADC studios. Welcome to our virtual panel discussion, Back to Basics, Improving Performance Through Digital Well Construction, sponsored by SLB. In this discussion, we're going to learn how SLB is leading the performance assurance charge in an increasingly digital landscape, evolving drilling by combining its latest drill bit technologies, rotary steerable systems, and autonomous controls. These are crucial advances for building wells in the most efficient and consistent manner and enhancing real-time reservoir characterization for more precise trajectories that elevate well performance. With me today is Roberta Santana, SLB product champion for digital and PDC bits. She's going to be highlighting the SmartScan app and dual grading digitalization. And Roberta's been with SLB since 2012, previously serving as technology lifecycle lead and Western Hemisphere asset planner. She has a bachelor's degree in petroleum engineering from the Universidade Federal de Rio de Janeiro and an MBA from the Quantic School of Business and Technology. Roberta, thank you for joining us for this discussion.
Thank you so much for having me today.
And over here in the middle is Wiley Long, SLB product champion for PDC bits and cutters. He's going to be discussing the evolution of Smith bits drill bits. And Wiley's been with SLB since 2005, having served previously as an engineering manager and drilling optimization manager before taking his current role in 2016. He has a BS in mechanical engineering from Texas A&M University. Wiley, thank you again.
Yeah, great, thanks to be here. Great to be here, Steve.
And on the far end here is Ziad Akawi. He is SLB digital champion. He's going to be detailing the company's autonomous downhole tools. He's been with the company for a while as well, 16 years, or a little bit more than 16 years. He has served in a variety of business development and product champion roles. He has a bachelor's degree in mechanical engineering from the University of Ottawa. So Ziad, thank you for joining today.
Good morning. Nice to be here with you in person. This is awesome to be here at the actual studio.
Thank you all again. So we're going to get right to the Q&A here. We want to remind you that you have a chance to participate in this discussion. We want to get as much feedback from our audience as possible. So if you have a question, if anything anybody says here today is something that you want to expand upon further, please submit your questions into the Q&A function on your screen. We'll try to get to as many as we can at the end of this presentation, and hopefully we'll have a little bit of fun here this morning. All right. So let's get right to it. Let's start with this first question that I have for you guys. A little bit of a introductory question here. Let's talk about the importance of what you guys are doing. What are you all doing? And where the idea of developing all these technologies that you guys are going to discuss, where did the idea for all that come from? Let me start with Roberta.
So definitely, as you mentioned, we've been in the industry for more than 10 years or way too many years, let's put it this way. So we all came from a season where the optimization of what we're doing was done by looking at Excel files, plotting, drawing. We come to a phase of the industry, any industry in general, that we can make our jobs a lot more efficient by having smart ways to look at information. And that's look at information, that's something that we always did. But that's how and how quick and how much improvement we can take in a shorter period of time. I guess that's the overall idea of our jobs, is looking into how to categorize information and how to put it in our favor a lot quicker, that we can advance performance, we can advance how technology expands a lot better than it was done 10, 15 years ago.
Wiley?
Yeah, so I mean, with the theme really being back to basics of what we're doing to enhance well construction, if we look at PDC cutters and PDC cutter development, for the past decade or so, at SLB we've put a lot of focus on developing shaped PDC cutters and how those shaped cutters can improve cutting efficiency and drilling performance. Really what we're seeing though with all of the new tools that we have today, and one of which Roberta will speak to a little bit later, is how can we get back to the basics of also making sure we're paying close attention to developing new materials. So whenever a PDC cutter is in contact with the rock and it's cutting the rock, we're putting a lot of energy into that PDC cutter, and we have to develop the best materials available, the best diamond materials to remove the heat from that cutting tip. And really, that's where a lot of our focus has been. How can we improve those cutting elements? How can we make them more durable so that regardless of the shape that we incorporate into it, we can continue to deliver that drilling performance, extend our drill bit footage and life.
Ziad?
For me, the importance of what we're doing is really driven by our customers' challenges and ambitions. Being a technology company, a lot of the motivation behind these technologies, especially in the digital era, is listening to our customers, understanding the challenges and their ambitions, not just from an economics point of view, but from a core beliefs point of view, health, safety, environment, sustainability. How can we develop technology to ultimately answer their call? And for autonomous directional drilling and what we're doing within Neuro Autonomous Solutions, it's really that simple. Listening to our customers, what are they interested in, what's going to ultimately affect their bottom line in reducing their cost per foot drilled or produced for oil or gas, and then how could we live up to the new operating model that we're seeing post-COVID and the drive for sustainability, reducing the footprint on the well site. So a lot of these technologies, a lot of the motivational factors that affected traditional hardware development is playing into digital. And although I would love to say, one of our brilliant scientists was walking in the park and he had a eureka moment and that's how Neuro Autonomous Solution was born, it's a lot more natural than that. It's a lot more involved. And I believe it's the natural progression of technology, especially in the domains like directional drilling.
You guys all hit on some interesting points that I think we're going to hit on a little bit here in this discussion with the safety element and performance and efficiency. But we'll just start here with this question, and maybe Ziad, maybe you can continue on and answer this one first. So which aspects or stages or parts of the well construction process do you think offer the greatest opportunity cost for digital systems to make an impact? And where do you see the greatest impact there?
Yeah, talking about autonomous directional drilling and autonomous solutions for not just directional drilling, but well construction as a whole, I think one of the biggest aspects is all around modern remote operations. Historically, we've done remote operations the past 5-10 years or even more than that, but it was never purpose-built for that purpose. We always leveraged third-party capabilities. With the technologies that we're developing today, especially around directional drilling, we've embedded remote operations at the heart of it. So when we look at the operating models that our customers are asking for, where they can potentially have MWDs and DDs sitting in multiple offices, in different offices, the dynamic that used to exist on the well site no longer is there. So you have to use digital elements to really bring out that value and to ensure the trust of operations is still there. So a lot of what modern digital capabilities has given us is to build trust around cybersecurity, to build trust around the fact that you can execute no matter where you're at, and that the fact that you're taking a system-based approach to something that was a little bit more human-driven without taking the personal aspects of human out of the loop. Anybody that's been in and around directional drilling will tell you it's characterized as a mix between art and science. So I think the digital aspect is allowing us to improve the science, the math, the automation of everything that goes into it, while allowing the directional drillers, the superintendents, all the stakeholders in the directional drilling process to be involved even in a remote operations setting. So this is where I believe, especially for autonomous directional drilling, the biggest impact that we can have, the biggest value that we can drive, and it supports multiple different aspects. The hardcore, let's get the cheapest solution possible with the best performance, but at the same time pushing us forward as an industry and as a domain with digital.
Anybody else have anything to add?
Yes, actually, the points that Ziad mentioned are very interesting regarding how to deliver the job well done precisely. And then when we talk about cutter technology like Wiley pinpointed, and now mentioning what we're delivering with SnapScan, because we usually mention that we cannot drill well without a drill bit, and we cannot drill well without a good drill bit that drives you to exactly what we want to deliver. But how quick we are interacting with how much good data we actually interacting, developing the next level of materials, the next level of designs, so the directional job can be facilitated, and then the consistency of the job can be in the same place. We don't want it to. We want to be one step ahead of improvements, or we want to analyze exactly where we need to put our resources to drive the performance, to keep drilling wells, to keep driving rate of penetration and the ability to produce more and to get better performance out of our technologies. But now looking at larger volumes of data, making it easier for the customer, because one of the things that we mentioned is that the user experience has to be involved. If the operators cannot easily participate in the process of delivering this optimization, we need to make it better. So part of SnapScan is exactly help them to collect large volume of data in a very easily manner. So we usually say that all you need to operate SnapScan is to use your phone. That's exactly all you need. Everybody has a phone, everybody has a smartphone those days, and everybody knows how to use it. So why not take advantage of the cameras and the hardware that everybody already manipulates every day, but now with the advantage of collecting good information that is going to drive our performance, drilling better wells, producing better materials, producing better products. And the power of this data and the communication that developed for the last decade or even the last 5 years, how quick the information gets uploaded in the cloud, how quick the information gets digested and comes back to you with good conclusions and good recommendations, that's exactly the way we should go, and that's exactly the way we're going with SnapScan.
Well, and our phones nowadays are so powerful, it makes sense to try to maximize them as much as we can. Everybody has a smartphone nowadays. Unless you don't, but most people have smartphones. Wiley, let's get you in here with this next question. So the industry has so much data at its disposal to help design wells. I mean, just tons and tons and tons of data. So in your opinion, what ways are the digital systems that we have available allowing us to make better use of all of this data?
Yeah, so I'll definitely speak specifically to drill bits and to cutting structures and our PDC cutters. We actually started in SLB is to start to digitize our drill bit design process and our drill bit life cycle all the way back in the early 2000s with the creation of our IDEAS drilling simulator. So IDEAS is essentially a time-based 3D finite element analysis tool that we can run real-time drilling simulations to be able to model the behavior of an entire drill string. So, but at the very foundation of IDEAS are these rock files where we take actual PDC cutters and we take actual rock, confine it under pressure, and we do scrape tests, physical scrape tests on these rocks. The importance of this is that we're building a broad spectrum of cutter-rock interaction. Dozens of different rock types, everything from sandstones and shales and limestones, different attack angles, because really what we want to understand is how is a cutter going to interact with the rock, and then we can integrate that across the drill bit, understand the drill bit behavior, because again, what we really want to get to is we understand that it's not very efficient or cost-effective for our customers to use their wells, to use their assets for us to behave as, or for us to use as a playground to trial and error. So we use this digital environment to design our products, iterate, tinker with our products to make sure that anything that we're going to deliver is going to be, we're going to have that high confidence in it before we ever put it in the ground.
Anybody else have anything to add?
Yeah, maybe I'll add, I think, looking at this panel, right, you have Roberta talking about SnapScan, which is making the lives of our customers or anybody associated with drill bits that wants to characterize the performance of that drill bit after a run super easy and super convenient. And then Wiley's talking about taking that data and essentially feeding into finite element analysis and physics-based modeling to not just characterize what happened, but how can we improve it for the next run to make the best job that we can in the next design phase. Directional drilling needs all of that, or well construction needs all of that to come together. And with the context of data, I think data has always been available, especially for us in SLB. We've always been historically a digital company with formation evaluation. So when it comes to well construction, what we've done with data, essentially contextualize it, and we've basically taken all that information and saying, okay, what could we effectively do with it? And a perfect example for Neuro is something that we've developed called predictive steering, which essentially builds on ideas, physics-based modeling for directional drilling tendency. Because before you go out there and actually automate the job, you need to plan it for success. You need it to plan it to go the way you want. So the best way to do that is to minimize the risk and uncertainty associated with that BHA, with that trajectory, the dog-leg delivery. So what we do is we actually created a machine learning model that takes in all the data associated with past wells that we've drilled, combined with physics-based modeling from ideas, and we reduce the uncertainty of the tendency analysis of the BHA. So that way, when we're designing the bottom hole assembly, when we're designing the trajectory, we can tweak it just enough where we improve our chances of delivering what we ultimately need to deliver, reducing the uncertainty, reducing the risk, and improving the consistency of directional drilling operations so that the autonomous system can do its work and deliver the well. So this is, I think, a perfect combination of traditional technology, physics-based modeling that we've always known, coupled with new data sources and contextualized data to actually deliver an advancement like autonomous directional drilling. And one thing, this one last thing I'll add in there was very interesting was, especially in directional drilling, we've always had things like, just do this because, or things that were passed down from directional driller to directional driller. And what we've learned through this predictive steering model is a lot of the stuff that we're kind of non-analytical, or we just know it to be true, we're starting to prove it with data, with execution data, and that's really the most exciting things. We all know as directional drillers that your inclination, your DLS, your yield at higher inclination increases. Well, we've actually now been able to prove it numerically over and over again and validated it across data sets that span years. So this is using data to advance the very basics of well construction, and I think this is a perfect example of how we're using it for our solutions.
It's got to be satisfying to be able to validate what you already knew or conventional wisdom, what you suspected. That has to be very exciting for you guys.
Absolutely.
So just a reminder, we've had so much great insight already here in just the first couple of questions. So hey, Q&A button is right there on your screen. Please, if you have a question for our panelists, send it, and we'll try to get to it as quick as we can once we get closer to the end of this here. So let's go on to the next question, and let's just see who wants to take this one on. SLB. Well, actually, you know what? I think Wiley's going to probably take this one on first. SLB has various enabling technologies for its cutting structures. Can you talk a little bit about the specific improvements that you've been able to realize through digitalization?
So we talked a bit about the ideas, and then really getting to what we're able to do now with PDC cutters and leveraging the data that we get now coming from SnapScan. So with SnapScan, now we're able to record the dull grade of every PDC bit that we run. And this is quite a step change and a quite different thing that we've ever done in the past, because in the past we have engineers all over the world. They would take pictures of their used bits and they would reside on their laptop and they would do some analysis. Now we're taking them at a centralized location, we're housing them at a centralized location where everyone can have access to them. Customers can have access to the dulls of the bits that they've run. All of our engineering from our field all the way into the R&D departments can access these different dull conditions as well. And really what it enables us to do is to start to build a picture of how PDC cutters are being damaged over time. Often, whenever you have a drill bit and you run it, it comes out, and if it drills the entire interval, let's say if it drills 10,000 feet, it comes out with quite a bit of damage on it. And all you see is a snapshot of this bit drilled 10,000 feet, and maybe it's got a lot of damage. What we're starting to see, because we can now house and sequence all of these different sets of PDC bit damages, maybe we get a bit that gets pulled a bit early. Maybe it only drilled 5,000 feet. Well, now we can start to paint a picture to say, well, how did the damage actually progress? maybe it looks like some sort of damage that came from some sort of impact type of damage, but we can build this picture of progression to kind of understand, well, maybe it was actually a different underlying symptom. And that's exactly one of the things we've focused on when we developed our ThermoBlade product. We saw that one of the more common dull characteristics that we're seeing is from thermal cutter damage. Intense heat is built up at the PDC cutter tip, and this causes thermal cracks to start to develop in a PDC cutter. And the answer to solving that is incredibly different than if we were going to adjust our materials just to fix PDC cutter impact. So we've been able to take all this knowledge, feed it into our R&D centers so that they can have a better understanding of exactly what is the right symptom to address rather than only looking at the final outcome of a PDC cutter or a PDC bit.
Dull grading's right up your alley here, Roberta.
Yes.
So do you have anything to add to this?
Yes, it's a very good point that I usually ask people how they are recording their memories. Because what the drill bit does, and because the drill bit's the first one to touch the formation, so every little scar and damage that Wiley mentioned tells a story. And even in the entire drill bit, every cutter, depending on where it's located, is going to be able to tell a different story of damages, of how the rock interacted, the vibration impacts, the thermal expansion, thermal damage. So the ability to capture this information, that's what's going to drive us further. And the characterization of damage on a PDC cutter has been in the industry for many, many years, way before they even thought about joining the industry. But it's still, the characterization is visual. And we are humans, we have our bias, and we make our mistakes. What SnapScan is doing is to create an unbiased system that characterizes the same way every time, every bit, doesn't matter where it was utilized. And this layer of accuracy and consistency, that's what drives us further. We can still characterize visually, we can still do that from our experience, but the ability to keep yourself under the accuracy and the consistency, like I just mentioned, that's what helps the entire development of not only the PDC cutter realm itself, how we optimize our designs, how we interact with the rotary serials, how we interact with the entire BHA. So the vibration or the dynamic levels goes to the optimized situation or consideration that we can provide parameters roadmap. We can study parameters roadmap to either extend the life of the bit, either extend the life of the run, or deliver the well as planned. Everything comes from the full understanding of the picture. And again, I ask again, how we actually recording it. In the industry, we all had our methodologies. We had a specific folder with a specific name. Our emails were very well labeled, but it's still where it's being stored. And like Wiley mentioned, the ability to have everything in an easily accessible database that allows all of us to create analysis very quick and take conclusions for the next step. That's the step change. That's what's changing right here.
And also leads to sort of questions about sort of standardization of data and just sort of, with this industry, everybody has their formats and what have you. So I'm sure that this type of system is definitely valuable in that area, I would think.
Yes, absolutely. It creates the standardization and allows quick access, doesn't matter where you are. It's taking advantage, yes, we're going through a very interesting learning curve in terms of cybersecurity and protection of information that also goes along with all the technologies that we're talking about, because it's information that gotta be well protected, and we are very versed and we have been putting a lot of effort and resources to make sure that this happens across the board, but it's still how to make it available on an easy format that everybody can read. It doesn't need to code a special language, it doesn't need to be expert in certain platform. It is as easy as accessing any website. You just go and check it.
Okay. Well, let's go on to this next question here. And Ziad, I talked to Roberta and Wiley here, so let's get you in on this next question. So how have the improvements in downhole hardware helped you in developing your various autonomous downhole technologies?
Yeah. Downhole components are very critical, right? At the end of the day, they're the tools that are actually doing the steering for us. So in our development of rotary steerable technologies or even the BHA components, we've come a long way, right? And this isn't a journey that we just started a couple years ago. We've been at this for a very long time. A lot of the advancements that were done to support rotary steerable systems with closed loop modes downhole, hold inclination and azimuth, power V, a lot of these things that really put rotary steerable systems on the map is the control algorithms and how the technologies actually function. What we've augmented that with modern digital automation or machine control is now the ability to balance downhole automation with surface-based automation. And that's why within autonomous directional drilling, we heavily focus on surface automation and downhole automation and combining the two. So what that meant was that now our technology development has to go hand in hand. Software, firmware, downhole, mechanical, they all need to come together to deliver a better overall product. And this is where we start to really look at it from a system-based approach. We need to have the right digital acquisition system on surface. We need to have the right interfaces. We need to have the proper modeling for the downhole tools and all the information that it could possibly be sent up. So that way we can make the best decisions. And sometimes those decisions need to be done downhole where we empower the rotary steerable systems to do that. Or at times we need to do that from surface. But what we've launched almost a year and a half ago, or a little bit longer, is what we call AutoCurve, is downhole autonomous control system, which is a revolutionary aspect of controlling or delivering curvatures with rotary steerable systems completely downhole without surface intervention. We just essentially asked the rotary steerable system to deliver a specific curvature, whether it be 2D or 3D, and then it's able to take measurements downhole, make decisions, and ultimately keep us on track. And then from a surface point of view, we have systems that monitor that performance, that monitor how we're performing versus the trajectory, and could make intelligent decisions on when we need to intervene if we need to. And the ultimate aim is to reduce the number of disruptions we're putting to the drilling process, reduce the number of downlinks, and ultimately make the best decisions we can in real time to minimize tortuosity and to deliver the targets as designed per the well plan. So that way the entire field development stays on track and the customer reaps the benefit, not just from a section or a well point of view, but even from a field development point of view. So it's become very critical that hardware, digital system, automation layers, autonomous, intelligence all work together seamlessly to deliver better performance holistically.
Simplifying well construction.
Simple, yeah.
Again, questions and answers. We were going to get to our questions in due time, so please send them on the Q&A button on your screen. We've got a lot to discuss. So, next question about AI and machine learning. These are some magic words in our industry nowadays when you hear people say stuff like that. So, from your perspective, how have you incorporated AI and machine learning into your analysis and planning tools? What kind of algorithms? How are you maybe you can't tell me exactly what algorithms you're using, but how are you incorporating them into your tools? And what kind of insights has AI and machine learning sort of helped you gain? Who wants to take that one?
I can take that. I can start this. And I would say that the last few months, AI became, like I said, the magic word. It's everywhere. And everybody wants to incorporate somehow in their systems. But the critical point on how to use AI is exactly where it's driving you. So the combination of AI with machine learning that SnapScan does is a combination of the recognition of the pattern and the classification of it. So it has to have a separation that when you recognize there is a damage on the cutter, how you're actually going to classify. And this classification depends on data. So yes, we did not start 6 months ago, we did not start even last year. Has been many years, and being in the drilling industry and being in the drill bits business, it turns the data collection a lot more intensive for us, because that is our bread and butter. That's how we live every day developing better information systems, better cutters, better products. And when we collect this systematically, it drives our accuracy on how to classify the very next damage. And that's how our machine learning embedded in SnapScan is operating today. What we want is to be able to classify any cutter at any time and use that information for the next step into development, or choose how to put the resources, where needs resources, who needs to have the quickest turnaround, and the optimization of time spent and intelligence. The intelligence, I guess, is the largest umbrella that we can put everything under. It's how to better utilize the AI for specific reasons, how to use our data to train our machine learning, and then move us forward. So SnapScan combines both, and I'm going to emphasize here, it's just on the phone. All we need is to use a phone. Very easy, very straightforward. And part of our capability is exactly to capture this desire of the customer, how they want to operate, in which environment, how much that information is capable to drive them forward and make it easy. So the user experience, and of course, combined with the user interface, how to use the AI, how to operate the machine learning, that's is going to drive us to the next step forward. Anyone else who wants to contribute?
Yeah, I just want to add, I mean, it's really what it's doing is it's enabling our engineers, our people who are trying to make these decisions to evolve our hardware and to constantly improve our hardware like drill bits. So one thing that's what I have always found interesting about drill bits is it's incredibly dynamic in that the bit design is constantly changing. And the speed at which you can change that bit design, that's what's quite important to deliver the performance that our customers require. So, in the past, where you're trying to look at different dull conditions, and one of the things really that I know the industry is working on is how to evolve even how we characterize the dull condition of the bit. And I would argue even one thing that SnapScan will allow us to do is, right now, the IEDC dull grade for a PDC bit, it's made up of 9 characters. 3 of them aren't even useful for a PDC bit because it was initially made for a Rollicom bit. I would actually argue, as humans, yes, we like a nice, tight little format exactly to characterize something, but if it's digitized, you don't want necessarily to be looking at all of the characterization of every single individual PDC cutter. What you want is an answer back, and that's what we're building in. The interpretation of, okay, I've seen this pattern over and over again, or I've seen this pattern 2, 3, 4 times. What do I do next? Mm-hmm. That interpretation, enabling the engineers to make the right decision more quickly, that's really where AI and the machine learning is going to drive our business.
What's the point of a digital system if you have to do more work, right?
Absolutely.
So you want it to give you the insight so that you can do other things.
Yes.
Ziad, what do you got to say about this? Chomping at the bit here.
Well, I mean, to complement what was Roberta and Wiley mentioned, I think a big aspect of AI and ML is not necessarily what it's doing today, but what it could do at scale. I think the biggest aspect, the biggest impact that it could bring to individual domains or well construction holistically is how fast we could actually industrialize these technologies, these solutions, and make it available on every rig, every field, anywhere we operate worldwide. Our customers do not operate one rig, they do not operate in one field. Some are operating in multiple different countries, very diverse conditions, very diverse challenges. So the key is what Wiley mentioned. How can you take all of the data that you're capturing, all of the domain knowledge that you have, and translating that into a tangible solution, answer, and insight that somebody could use to make a better informed decision that ultimately impacts the overall performance in well construction or a specific domain. And this is where I go back to neuro-autonomous solutions and directional drilling. Predictive steering really opened up our eyes in terms of the value that we could bring with the simplicity. Although people think AI and machine learning is fairly complex, and to a degree it is in the background, but at the end of the day, the users that are going to be using these insights, the systems that will rely on these answers, have to be simplistic, right? We cannot overcomplicate it for the sake of operations. So what we've learned with predictive steering for tendency analysis is essentially without modifying the workflow for our drilling engineers, the system works in the background and only gives them an answer natively as they're doing their work. So we don't disrupt their workflow, we don't add more complexity, we just make their work more enriched with data, with information, so they could make better judgments. Do I need to tweak the dog leg? Do I need the tool face? What machine learning brought to us, the best drilling engineers, the best directional drillers, we could look at 1, 5, 10, maybe even 100 wells and try to see, okay, what can we learn? What could we do different? With machine learning and AI, you have data sets that could be thousands of wells. It could be hours and hours of real-time operations, stuff that we physically cannot even comprehend. So these systems really highlight stuff that we've missed in the past and allows us to continuously improve on what we've done in the past. And I think this is the really exciting aspect of ML and AI is how can we get these answers at scale so that our customers could reap the benefits across the board.
Well, let's go on to this next question then. What are some of the key performance indicators that you guys are looking out for with these digital systems we're discussing? Ziad, we already were going here. Why don't I just go back to you, see what you think about this?
Yeah, I mean, with neuro-autonomous solutions, we're mainly tracking a couple of different attributes. We're looking at, obviously, how well we're able to deliver execution per plan. When you think of it from field scale, you do all this extensive planning, and then if you go into execution and that's thrown off, it doesn't just throw off that well, it throws off all the logistics associated with everything that comes after drilling the well, the domino effect of the wells to be executed after that. So it's really important for us to actually monitor, are we able to execute and deliver what was planned? So that's number one for us, and that could come in different ways, whether it be AFE or whether it be, plan versus actual, hitting the targets. Are we in the correct pay zone with the right percentages that's needed for production? So that's number one. Number two is also how much we disrupt the drilling process. As I mentioned before, a lot of the advancements in downhole autonomous control and what we're doing from surface is how can we send the least amount of downlinks? How can we disrupt the drilling process the most? So for us, we track how many downlinks we're sending, how much we're interrupting the drilling process, and our aim is, on average, to possibly reduce up to 50% of what traditionally used to take place or needed to happen to directionally drill a well. And thirdly is the performance, overall performance. At the end of the day, we still want to have the best performance possible, but now at scale, which means we don't just want one rig to perform the best and then you have laggards on one side or to the other. How can we shrink that bell curve and make sure all the rigs are operating in the performance envelope that is possible and for as long as possible, right? We don't want just the best well, we want every well to be the best well. And this is where automation, autonomous directional drilling really shines, because we can standardize processes and we could depend on a system-based approach that could give us efficiency and effectiveness of delivery, which should shrink that bell curve. So those are the couple of things we're looking at that's been important for directional drilling. I don't know if you guys want to add from bits or...
Yes, absolutely. So when we look into the data collection and the possibilities that we can do regarding digitalization of a drill bit, we are, and I'm glad as Ziad mentioned a few times, it's delivering at scale and with consistency. We don't want only one good design. We want every design to be the next good one, the next best one. But at the same time, it should deliver performance. We are still at a business to deliver performance, to drill wells and drill good wells. And the enablement and the empowerment of our customers to exactly look at data the way that we always did. We always very appreciative of drill bits information, and we all took very good care of the images and the pictures that we were looking in the past. But how much more we can get if we put it in the hands of everybody, and that's the disruption, and that's the next step that SnapScan is enabling. Is bringing this information to the rig level, because it's so easy to maneuver and it's so elegant to have this information back to the teams, that you bring this conclusion and the agility to the field at the rig level together with the technical team sitting at the office. So it's the broader spectrum of the expertises that we embrace. It gets out of it. We are not going to stop being drill bits experts, but now engaging with the industry on a whole nother level.
So we're already getting questions in, so we're going to get to them in just a minute. Thank you for those who have sent, and please, we got a little bit of time. You got more questions to send, you know where that Q&A button is. Send them and we'll get to them. But I've got one more question before we kind of get into this part of the discussion and, a little bit of a roundup of everything that we've discussed here. Maybe a little bit of future casting, I don't know. Where would you say well construction's headed? Where's the future? What are the next advances? Where are we going with all this? Who wants to tackle that first?
I mean, I'll start. Because where the cutter meets the rock is the first part of the drilling process. So again, we're using all the data available to better enable our engineers to make these quick decisions. And it's on a couple of key timescales. It's what can I do right now? How can I fix a bit that's coming in for repair? What cutters do I want to put into that bit so it's going to make the best performance? And then it's also on a time frame of, well, what is bigger picture? What are the themes that I'm seeing of how PDC cutter damage is accumulating? And how am I going to address that from more of an R&D perspective? So all of this information coming in, we're just continuously to improve it, because one thing that I've seen in drill bits over the past 20 years is you will never find a customer who is just completely satisfied with, yep, this is the one drill bit I want to use for the rest of my life. You take a drill bit, you let it drill its interval. If it comes out with no damage, the customer will look at it and say, I didn't push it hard enough. So the next thing they're going to do is push it harder. They're going to find how to break something on that drill bit. And that keeps us busy, keeps us actually employed as well. But it also keeps a nice competitive nature into the environment. And we're always pushing for faster. How can we reduce the amount of bits to drill an interval? And the intervals are getting longer too. Laterals are getting longer. We want to be able to utilize more space within the footprint that we have on a drilling pad. So our customers are pushing these wells farther and farther, and so we have to continue to make the drill bits that can deliver these with the pace and performance that they expect.
The 3-mile laterals are becoming more commonplace now. You're going to just world of stress testing in your guys' world. Anybody else want to add to this future casting question?
Yeah, I can jump in. When I step back and look at what we're doing, where we've come the last couple of years and where we're heading, I often tell people when they ask me, what do you do? I say, I'm just like a little kid in a toy factory, right? A lot of the stuff we dreamt about when we're sitting on the rigs in between casing breaks, thinking about what actually happened. A lot of the stuff that we're actually thinking about is now materializing into real technologies. A lot of the natural progression of directional drilling automation, well construction automation, leveraging every piece of data you have to make the best decisions, that's reality. That's today. This isn't a dream. This is actually happening. And when I look to the future, what really excites me is autonomous operations holistically, not just in a particular domain, but cross-domain, across well construction, tied with rig automation. This is something that I think is inevitable and natural progression to where we have come from and what we've seen over the past couple of years. But I would say the biggest thing that really excites me about well construction, specifically what we're doing within SLB, is how can we leverage every piece of data and information cross-domain to make the best informed decision for our customers that ultimately result in better economics, better performance, lower risk, lower uncertainty, and improved efficiency. And this to me is really a testament of SLB's well construction division. We have fluids, equipment, directional drilling, measurements while drilling. And when I look at neuro-autonomous solution and what it could look like in the next couple of years, autonomous geosteering, using the latest and greatest imaging technologies for LWD, combined with the latest and greatest rotor steerable systems, with an intelligent system to tie it all together. This is what really excites me. This is what I think the future is headed for us. And I think this is where SLB will continue to shine, given our domain expertise across the board, not just in directional drilling, but formation evaluation and well construction as a whole.
Absolutely, Neil. Thanks for that, Ziad. I was about to say that within us, we are very we work very well together, I'm going to put it this way. In data and the ability to combine information, that is one of the drivers. We talk the same language, we get into conversations way better informed than it used to be 5-10 years ago, because now we can see each other's tool behaviors, each other's performance, and be way more integrated than it used to be 5-10 years ago. The ability to deliver one combined good solution that approaches exactly what the industry wants or what our customer wants to have. Our capabilities to do that together with digitalization in the way that we're moving forward is not going to stop today. It's not that we are satisfied the way that our digital solutions stand today. We are very proud of what we can deliver, but we have much more moving forward. Technology is there to evolve, and we're going to keep following this path with our expertise back when we were just operating Excel sheets, but now looking at data and looking at information from a whole nother perspective.
All right, so now it's time for the fun part. Not that this hasn't been fun, but we're going to get to the really fun part here, your questions and answers. We have so many questions that have come in and so little time to go through them, so we'll try to get to as many as we can, and hopefully we'll get some really good insight here. We're going to get to this first question all the way from Abu Dhabi. Thanks for tuning in at this time of day over there. Let's just answer this one. Can you please elaborate on how each type of vibration effect bit and what design improvements have been made to minimize this problem? So I guess looking at different types of vibrations, or like I guess maybe the downhole dysfunctions and things like that, taking into consideration the extended reach drilling wells with tough wellbore conditions. Who wants to take that? Maybe Wiley should take that.
I'll start with that. So again, I will go back to, that was always the intent of our physics-based ideas simulator, is to be able to model these scenarios and see what is happening all throughout the drill string in a virtual environment. And really what we've been able to do over these past several years as we increase the amount of measurements that are going on downhole. So from all of our measurements tools, almost every measurements tool in the BHA has some sort of vibration recorder. And we also need to be careful. I mean, there's several different types of vibration, so it helps us to identify what is the mode of vibration. And so we're looking at that all throughout the BHA. These are things we record and we can look at after the fact, and we can use those measurements actually to now go back and calibrate and recalibrate our simulator. Once we have this really accurate, I like to call it more almost like a drilling avatar, an application avatar, now we can do these what-if scenarios. You know, what are we trying to address? Are we trying to address high-frequency torsional oscillation, bit whirl, stick slip? We can simulate all these different things, and then we can start to tinker. What do we want to do? Do we want to modify the drill bit design? Are there different componentries, different placement of the BHA components that we want to move around? Or are there different drilling parameters we want to adjust? Is there a sweet spot of weight on bit and rotary speed to give us the best outcome?
Yeah, and we've done quite a bit on the execution side as well. I mean, after the fact is always good for design, engineering, and to evolve the products. And this not just is confined to drill bits, right? The entire BHA string suffers from damage when we encounter drilling dysfunction. So what we've done from an automation point of view, especially with DrillOps Automate and a lot of our rig products, is to handle that in real time. So system-based approach to stick slip detection and mitigation, shock and vibration. We have the capabilities now to automate that entire process, the detection and mitigation measures that need to take place to solve that problem in real time. And this is where we've seen a lot of good results from our international deployments, where they're leveraging the entire DrillOps automation suite. And this is where we've saved a lot of damage and a lot of possible trips that were prevented by taking care of those types of dysfunctions in real time. And it's all about energy management. When you're fighting dysfunction, you cannot also optimize ROP at the same time. You need to handle your dysfunction first and then go to optimization afterwards. So a system-based approach makes it effective, efficient, and we've seen quite a bit of success with the automation solution to tackle that problem in real time.
And we're getting more and more questions coming in, so let's go to this next one. And Ziad, I think this might be one for you, although everybody else might have some thoughts on this. When you refer to autonomous directional drilling, what do you mean? Is this just auto steering, or does it also include ROP optimization, fault detection, other things?
Yeah. So it depends, right? We have various deployment capabilities and different functionalities. You know, the complexity of an autonomous system is scalable with what we bring to the table. So with what I just described with the drill ops automate and autonomous directional drilling, it goes hand in hand. So autonomous directional drilling, or the DD advisor aspect, takes care of geometrical steering and the downlinks or the slide rotate sequences we need to deliver the trajectory and the targets, while our automation energy management solution looks at ROP optimization, shock and vibration, stringer detection and mitigation, and combines it all in one. You know, we're fortunate enough to have developed drill ops holistically across the company. So we take advantage of a lot of cross-domain aspects to come together to deliver something like directional drilling. But where we stand today is geometrical steering. We're looking at downlink mapping and tying it to the automation solution. So we truly have a hands-off directional drilling experience, and coupled with ROP optimization, shock and vibration, and dysfunction mitigation, it all comes together to what we call autonomous directional drilling.
Well, Roberta, maybe we'll get you involved in this little Q&A here, and maybe Wiley can get some insight here too. Can you give an example of how you used SnapScan on a specific bit design and learnt something from the scans that made you change and improve the design for the next bit run?
Thanks for the question. So internally, what we have been using for quite some time now is that the ability to quickly understand a large volume of downgrading information to take decision on what to change and what to adjust for the next design. So back when I was in the field, it would take me at least a few weeks to be able to take notes, select the pictures, and take conclusions as which area of it's the comb, the nose, the shoulder, the gauge, where the damage is coming from, maybe matching with the patterns, understand if it's vibration, if the cut is getting damaged, if it's a change in design, if it's a change in hydraulics, all this information that goes along with the drill bit performance that it takes time to put together. What SnapScan allows you to do is to through the scans, and of course the collection of the downgrading, that's what might take longer, because then you have to wait until every bit comes to your hands and then you scan. But the quickest you can get is information in the system. So let's say you have 5 bits ahead in front of you, you scan, in a few minutes all this information is computed and digested, and then you can plot side by side together with performance, together with dynamics, together with downgrading damage cutter by cutter. When you look, like Wiley mentioned, the IDC formatted as it is today, summarize the damage. So you look at one average number for the inner cutters, one average number for the outer cutters. But can you really see what's happening in blade number 3 in the shoulder? Not really. So that's what SnapScan drives you. It drives the understanding on where the damage and what it's actually failing. So and we usually say behind the curtains or within us that a cutter that stays sharper drills for longer and better. So modifications in the cutting structure and modification on the choice of the cutter, that's what very quick can impact the performance of the drill bit. But then comes to, that's on our side, then comes to what our operators are doing with the data. It's also this understanding or the perspective of what to change at the rig level. If they get a bit that looks damaged right on the spot, they can already take a decision on what to do with the very next bit. Maybe it's the damage that they are not used to see, so they can quickly plot against their offset information and quickly plot against all the other dull damages that they have in that field, in that application, and compare very quick. And again, take decision on what to do on the very next well, which in the past would take us weeks, or it would take us a few wells ahead to take the decision. Now it can be done on the very next run.
And just to quickly add to that, so what we do a lot as well is all that data that we collect, each individual PDC cutter, it's housed in a position on a bit, and we add all that extra context to it. You know, what sort of environment was that bit exposed to? What sort of cutter loads was that exposed to? Because As a bit company, we have dozens of different PDC cutter grades of different toughness values, different wear-resistant values, different shapes. And so if you're an engineer in the field trying to customize this product for a customer, it can be challenging. Sometimes it can be overwhelming. So as we get these runs, as we get these records that come in that show how our cutters are damaged for different applications, once we contextualize that, now we're able to build these links. We say, oh, if you're seeing this type of PDC cutter in this type of environment and you're seeing this type of damage, yes, now switch to this one. We know from other applications around the world where making this change has delivered a positive outcome.
Now, I love this next question. It could probably be its own panel, but maybe we can get the answer in 1 or 2 minutes. But let's go with this question here. Does the panel think that we should concentrate on ROP, rate of penetration, or enhanced rate of progress? We've spent the last 3 years trawling through DDRs and EOWRs and find that the bit on bottom is less than 20% of the overall time. So the bit-rock interaction is critical to reducing weld times, particularly in higher strength igneous and meta sediments. What do you guys think about that?
I think I'm going to jump in first.
All right, all right.
I love this question because it's very, very true, and I think anyone that's looked at the evaluation of the well construction process will state the exact same thing. But I think for us to advance as well construction, or to help our customers advance with well economics and overall performance, you have to do both, right? You have to still develop technologies that will allow you to push the limits on bottom to get the most that you can from the bottom hole assemblies. And this is what we've seen transpired not just over the last couple of years, but I think the last decade or more. With every new hardware that we've developed, it was intended to improve something in the drilling process. But at the same time, I think digitally, this is where automation and system-based approach is trying to solve the other problem as well, which is how do you reduce flat time, dead time? How can you disrupt the drilling process less? And that way you affect both the on-bottom performance and off-bottom performance. You essentially, we used to call it invisible lost time. These invisible lost time events are now visible, and we can take actions to actually address them. So I think you have to do both. You cannot just focus on one or the other. Now, with some drilling programs, one might be bigger than the other, but that goes back to the engineering team behind it. But I think you have to do both, especially from a technology development point of view, and especially from a digital aspect.
Anybody else?
Yeah, the only thing I'll add on to that is, yes, drilling, it is becoming, I suppose, less and less of a percentage of the overall well construction time. And that's because of the advancements we've made. I would say, I won't attribute 100% to the PDC cutter technology, but it's certainly been a big part of it for allowing our bits to drill farther and faster and for longer periods of time. But even with that, we still have to develop. Again, going back to a statement I made earlier, I've yet to find a customer who is 100% satisfied with that drill bit. There's always something they want to squeeze out of it more, and we see it in the nature of the behavior of our customers, how intimately they want to get involved with drilling and drill bits and reducing that time. There's, in a lot of drilling departments that we go visit, they're almost quite competitive, even between the two drilling teams. Oh, we set a new ROP daily record. So, yes, there's a fun part of it, I think, too, that needs to remain as well. So we shouldn't just ignore it altogether.
All right, I'm going to get one last question in before we go, because I also really like this question, and hopefully maybe 30 seconds. We'll see how little time we can take on this one. But how autonomous are these new autonomous controls? Are we seeing a fully automated system during the execution stage?
I would say yes. I mean, when we came out with autonomous directional drilling, we communicated that this is going to be a journey, right? This isn't going to be a once and done kind of thing. We are constantly working on evolving that capability and expanding it from domain to domain. Like I mentioned, although right now between, say, a slip-to-slip automation where you essentially give system control to everything that happens from just after connection to getting on bottom, drilling, executing directional steering, that is all happening today autonomously on the rig. what is to come is how you evolve that to the broader well construction activities, and more so for formation evaluation geosteering, right? So I think, when we discussed autonomous directional drilling, we laid out 6 levels of autonomy. We are sitting today between level 3 and level 4, depending on the capability on the rigs and the operators. And we think that to get to level 5 is still going to take a couple more years. And this is where it starts becoming a multi-domain aspect, right? Well construction is holistic. It's not just DD, it's not just MWD, it's LWD, it's mud logging, it's surface logging, it's fluids. All of these things need to come together, and you need to have a platform that's able to do that, and this is what we're building, and we'll continue to work on to reach the ultimate ambition of full autonomy.
All right, guys, thank you so much for giving us all of this great information and all of this insight onto the tools that SLB has been developing and where we are with digital well construction. And I'm sure based on the engagement that we had today, this is something that's been quite an interest within the industry, so thank you all.
Thank you very much.
Thank you for your time.
And thank you for watching our virtual panel discussion in Back to Basics, Improving Performance Through Digital Well Construction, sponsored by SLB. I'd like to thank SLB for sponsoring this discussion and thank all of you who came in and submitted questions and watched us today. And a quick reminder that a recording of this presentation will be made available shortly, so be on the lookout for that if you want to go over and listen to what everybody said here today. I'd like to thank our panelists one more time for speaking with us. Thank you for visiting, and we'll see you soon.
Pretty better?
Yeah, that was.
You did great.
Your first live, you did great.
Yeah.
You did great.
Went fast. Huh?